So Jiva, all programming relies at some point on collecting data together in some way, either ordered or unordered or storing it away. The concept of collections is fundamental to really achieving almost anything in development. So in Foundation and Objective-C, what do we have on offer to make life work?
Sure. Just like NSString, again, a standard library for a language wouldn't be worth its salt if it didn't have a really robust collection of, collection classes. And so again, we're really fortunate that Objective-C, through the Foundation framework, has a great collection of collection classes. For example, it has an array class in NSArray, and of course, just like NSString, there's also an NSMutable array. So you've got the immutable version and the mutable version. Then there's also NSDictionary. Now, so NSArray is an indexed collection of items. So you can access elements in an NSArray based off of the index of the item in that.
Basically, its position in the array.
Right. It's called an ordered collection, essentially, which means also that its elements are kept in the same location that you put them in. So if you put item 1 at one location, item 2 at another location, then they will keep those locations relative to each other in the array. Then there's NSDictionary, which is an associative collection, which means essentially that you have keys and objects, and you insert elements with keys, and you can access them based off of those keys. Now, you don't have any real guarantees as far as the order that they will be actually physically stored in, but the idea is that you don't really care about the order in that case because you can access any one of them basically randomly.
Yeah, I mean, I like to think of a dictionary like when you do a coat check, and you hand your coat in. You've got no idea which hanger or where they're going to put it in the coat, but basically you've got a key in the form of your ticket that will get you that back when you need it.
Precisely, yes. And then also there's NSSet, which is an unordered collection of items that allow you to just work with groups of items, basically. It's kind of another one of those collections. In addition to that, there's also several specialized collections that have been added just recently to go along with garbage collection, and we'll take a look at a few of those. They're kind of cool, but they're probably not something you're going to use on a day-to-day basis unless you have a very specialized use. So we'll just kind of briefly visit those. But let's take a look first at NSArray and some example code. So here we've got a case where we are constructing an NSArray object. And in this particular case, again, we're using another one of these factories, right? And in this particular case, the factory is array with objects. This particular factory method takes a list of parameters, just like we've specified here. So 1, 2, so forth. And that list of arguments has to be terminated by a nil so that it knows when to stop looking for more arguments here. So we've got 1, 2, nil. So this will actually create an array with these objects inside of it, the 1 string and the 2 string. So if we then print that guy out, we'll actually see this array with those values in it. And this is, again, remember I said that we'd see some more examples of description methods of this %at format specifier printing stuff out. We're going to see here shortly what array looks like when you print it out using %at.
So again, I guess it's worth just reminding ourselves this is an NSArray, it's immutable. So once those objects are in the array, that's it. The array is fixed. You can't change the objects in the array, add objects to the array. It's about setting up an array that you're then going to use but not change.
Correct. Now, on the other end of that spectrum is the NSMutable array, right? The mutable version of array. In this particular case, we've actually just created this array. Again, we're using one of these factory methods that doesn't contain create or alloc or any of those things. So it's another one of those auto-released guys. And in this case, because it's a mutable array, we're actually able to add objects to it. So we've gotten the mutable array, and now we're able to add new objects to it.
Adds object just sticks it on the end?
It does. It just appends it onto the end. Now you can also insert objects into arrays at particular indexes if you choose. We'll see how we do that in just a few minutes. So just to give you an idea of how this works, let's take a look at how that looks when it actually prints out. So as you can see here, we've got, this is our first array that we're printing out here, and this is that example of that description method that is being called. It's essentially doing an open parenthesis, and then each of the items in there separated by a comma, and then a closed parenthesis. That's the description method of NSArray.
So I should imagine that what the NSArray is doing internally is it's going through all its elements and asking all the objects within it for their description methods.
That's exactly what it does. So essentially it says, here's my open parenthesis. Now I'm going to go through each of my elements, get the description for each of those, stuff it into my output, and then put a close parenthesis on the end of that. So that kind of gives you just a rough idea of sort of what we're talking about here. The idea is you're putting these things into a collection. Let's take a look at some more concrete examples. So again, I just showed you this this array with objects. That was the factory method that we were looking at there, and then the array. The mutable array where we're adding an object. If you wanted to insert an object, you could do array insert object, and then specify that it's that allows you to insert an object at a particular location in the array and so forth. You can also iterate over these arrays. So remember we talked about fast enumeration with these arrays, right? So imagine we've got this array with objects, and you've got foo, bar, baz are being filled into this array object. You can use that fast enumeration that we talked about back when we were talking about looping and stuff like that, right? So you can do this NS string item in array, right? Mm-hmm. And use that to print out each of the elements of that array.
That's really nice, simple syntax. Mm-hmm. That has just made an assumption that every object in the array is a string.
It is. You could, of course, that's an interesting point, because when you're working with these collection objects, they actually store everything as ID types. So you can actually, this could be rewritten, for example, to be ID item in array. Now, the truth is, if you did that, it might be slightly slower than if you actually specified the actual type of the value that you're getting out of there. Because down here, when it goes to do stuff with that, it has to do that extra work to find out what type of object it is before it dispatches the method calls to it. But that would be perfectly valid too, because inside the NSArray, those are stored just as ID data types.
So you can stick any type of object in an array?
You can stick any type of object in an array. You cannot stick scalar types into an array.
Oh, so we can't put integers and floats?
Correct. Well,
as integers and floats.
As integers or floats, which is actually going to be the section that we talk about next, which is how to box integers and floats and things like that so that you can put them into arrays.
But it doesn't matter, when we create an array with strings, it can have strings, it can have our own custom objects, it can have a mixture of anything in.
Right. Not only can they be any type of object, but they can be a mix and match of different kinds of objects in the same array.
But it assumes it's up to us to know what objects are in there at what place.
Yes, and that would be a little bit of a mess to do something like that. Although, if you wanted to do something like that, I suppose I shouldn't give you a weapon that you could hurt yourself with, but I'm going to anyway. You could, for example, if you did something like ID here, then you could, inside of here, you could say if item class is such and such. You could actually ask the item there what kind of class it is, and then do some kind of switch inside of your loop based off of that. Don't do that, but you could, and I'm sad to say I have written code like that here and there.
Someone out there now is trying that. And
somebody's going to, I'm sure. Yeah.
In a few months' time, I'm going to get an email telling me, why did we ever suggest
why did we say
that?
Sorry. So anyway, so that's something you can do. But it's more or less just to illustrate the point that you can put different kinds of objects in these collections, and it doesn't hurt anything. You can also, again, we talked about how this is an ordered collection of items, right? So you can access items at particular indexes. So, for example, in this case, we're looping over the array, getting the n, or having n set to each element's index in the array, and essentially this code and the code up above it do exactly the same thing. It's printing out the description of each of the objects in the array, and it's doing that by using the object at index method off of the array to actually get those elements. Finally, of course, we talked earlier about, when we were talking about loops and things like that, we talked about the old style enumerators, and that's exactly what this is here, this enumerator where you can get the object enumerator, you can then get the item, and you can get the next object, and you can loop over those. So again, this is doing the exact same thing that the previous code was doing, it's just another form of that.
Before we move on here, we may be covering this in a minute, in which case you can just tell me to be quiet again. But the object at index, it's probably worth pointing out, because it's not always the same in all languages. Array indexes start at 0.
They do start at 0.
So your first object is at 0.
Right.
And trying to access an index that is not in the array, in other words, if I've got 9 items and I try and access 10, or actually if I try and access 9, because it starts at 0 to 8, bad.
Yes, you'll get an exception. So don't do that. You want to make sure that when you're asking for a particular item at a particular index, that you are making sure that you don't have any off by 1 errors. It is 0 based, so make sure you're not going off the end of your array. Definitely.
And the array has a count method.
It does. There is a count method. In fact, actually, it's used right there. Array count.
It tells us how many are in there.
Exactly. Now, one thing to know about that, of course, is this is a little bit of a gotcha here. You're going to get an array count. Let's say you have an array with 10 items in it, right? What's the index of the last item? You were just talking about that. 9, exactly. So count will return 10. If you try to access the 10th element, then you'll get an error. So you need to make sure that's one of those off by 1 errors. You need to access the element at index 9 in a 10 element array. Make sense?
Yeah. I like just a handy little method on NSArrays, last object.
There is
a great one, because it just gives you the last one in the array, and if the array is empty, it just gives you nil.
Yes,
it doesn't blow up.
Yes, there's an element, or there's the last object method off of array, which will do exactly that. It gives you the last element in the array. So good stuff. In fact, here it is.
Oh, okay. I'm jumping ahead of you. I do apologize.
That's all good. Here's some more examples. Right, this is basically demonstrating indexed access. Again, we've got this array object here. We've got this item guy here. You could go get, in this particular case, this array has been filled with foo, bar, and baz. So item 0 is foo, item 1 is bar, item 2 is baz, and it has 3 objects in it. So if we then say, I want the object at index 1, then we're going to get back bar, because that's the item at index 1. If we were to say we wanted the item at index 2, then we would get baz. Same thing here. We've got this last object method that we were just talking about. In this particular case, foo bar baz, that's going to return baz, right? Another useful method is the method index of object, which will actually take whatever parameter you pass to it and will return the index of the object that is equal to that object.
So your code there is relying on that magic static string pointer stuff we were talking about earlier.
Well, no, this is actually going to do, this will do an equals, this will do an is equals to get back the value. So it's going to take this and it's going to say, for each one of these, whichever one is equal to, using the is equal method. So that will actually
check the value of a string in there.
It'll check the value of the pointer. Yes. Now there is another one that will do exactly, I believe, exactly what you're talking about, which will say, I think it's index of object identical to, or something along those lines, which will do it based off of the pointer.
It'll be in the docs.
Yeah. So that's the gist of essentially indexed array access. You can also access groups of objects in an array. So again, we've got this same old array here, right? Foo bar baz. You can specify a range. NS range is a structure that's part of Foundation, and it has 2 elements on it, a location and a length, and it's used for specifying a range of values. And in this particular case, we're specifying a range of values that begins at element 1 and has a length of 2 elements. And by using that, we can then create an indexed set, or an index set, which will give us a set of indexes of objects that we want to retrieve from our array. So then we can use the method objects at indexes, I should say, to pluck out objects at all of the indexes that we have created here.
So that's going to give us a new array
Yes.
that contains 2 items, bar and baz in this case here.
Correct.
Based on the... Okay.
Yes,
That's really
exactly.
cool for just grabbing stuff in the middle and not having to write looping code. And
Precisely. That prevents you from, for example, saying I'm going to start at element 1 and going through and, if the count is greater than 3, then I want this thing. And then when it reaches 5, then I'll stop counting. You can just say, give me elements 3 through 5, and it just gives you an array with those.
so if you put a length in that's longer than the array, does it blow up?
It will.
Yeah.
Yeah. So you don't want to do that.
It's becoming a common thing, isn't it? If it's longer than the array, it will blow up.
Indeed. So now here's an example of you can also do operations with the elements of your arrays. So you can take an array, let's say you have an array of objects, and you can say, I want to do something with every one of the objects in here. So for example, let's say that I have an array of employee records, and I want to give all of my employees a raise because, I knew you were going to smile at that. So I want to give all my employees a raise, right? So to do that, essentially, let's say we have this employees array, and we have this object called raise generator, which will enable you to pass in something that will actually create a raise for the employee based off of how much they make already. Maybe you want to give 10% to somebody who is, at a certain pay level and 20% to somebody who's at another pay level. So you can kind of equalize things out, right? So to do this, you can actually use the make objects perform selector method. This is a really cool method because what this lets you do, right, is it'll actually loop over every one of the elements of your array, and it will pull out those objects, and it will tell that object to perform the selector, in other words, call the method that you've specified using the @selector parameter here. In this case, it's giveRaise. So it's going to call the giveRaise method on each one of those objects. And it will also pass the object that you've specified here with the withObject parameter, the raise generator. So it'll go through all of those things and call that method on each one of those, passing that object to them. So in other words, just to give you an example with that employee object up here, right? Let's say the giveRaise method looked something like this, where you've got this giveRaise, it's taking this raise generator in, and you use it to set the salary on that employee by giving them a raise. Really cool stuff.
That is really powerful.
It really is. There are very, very few compiled languages that have this kind of power.
So are we limited to methods that take a single parameter? Because it's with object.
I'm not sure. I think there are some other methods that have the ability to pass additional objects, but I'm not sure off the top.
Okay, so we need to look at the docs. But the point is, there's a principle here that this can be done.
Right. I mean, worst case scenario, right? You could make this object be something that has other objects inside of it. So you could pass in like a dictionary, for example. You could pass in an NS dictionary with a bunch of other objects inside of it, and use that to pass multiple arguments to your perform selector.
Great.
So that's one way to do it. Another cool thing that you can do with arrays is you can sort them. If you've got a mutable array, you can sort it right in place, or if you've got an immutable array, you can sort it and get back a new sorted array. So one of the common ways that you do this is by using a sort descriptor. So again, let's say we've got this employees array that now contains our array of employees that are all making lots more money. And then we can create this sort descriptor to sort that employee list based off of their last name, so that we can randomly choose to fire someone with a last name of Z or something like that. So we've got this sort descriptor, and what this does, this is another one of those classes. You should look at the documentation for it. But basically, a sort descriptor allows you to specify a key to off of the object to sort by. So in this particular case, the sort descriptor is specifying that I'm going to sort this array based off of the last name property on my objects. The key that's specified here maps to the properties in the object itself. So here we're saying sort by last name. And then I can say create my array with objects. I then create an array of descriptors to pass to my method. This is
so we can have multiple sort descriptors.
Right, so I could say last name, then first name, then whatever.
And then we set up an array of those descriptors, and I guess the order of the descriptors in that array will be the sort order.
Correct.
If you're having multiple descriptors.
And then finally, I can use this sort using descriptors method to actually sort my employees array using those descriptors.
So because this is a mutable array, it will change the order of the objects.
Correct.
In the array. If this was, if we were doing it on an array, we'd need to do it and get back a new array.
Correct. Okay. Now, another way to do this is actually to use a custom sorting function that you can write yourself. Let's say you didn't want to just sort based off of a property, but you wanted to do something a little bit more custom, like create a function that would take these two objects and do some kind of custom comparison, or maybe even it'll go look up these objects in another database or something to do sorting, some kind of weird complex sorting, right? So in this case, we've actually created a method or a function here called sort by employee last name, and that takes two employee objects, and notice that I'm passing these as ID objects. That's part of the requirements for this kind of sorting, is they have to be passed as ID, because of course the array is going to be storing them as ID. And then a context pointer. And essentially, all I'm doing in this particular one is I'm doing I'm taking employee 1 and employee 2, and I'm comparing their last names and returning the comparison result of that. So effectively, this is doing exactly the same thing as the code up above. It's just I've written a custom function to do that. So again, if we've got an array of employees here, then I can use this sort using function call off of the employees array, and I can pass that sort by employee last name function there, and then the context pointer that's provided here is what will be passed into that void pointer CTX at the end of that. So that again, this will sort that array just by using that function. Finally, you can also filter your arrays. So you can get back a subset of your array by filtering it using another class here called NSPredicate. NSPredicate allows you to specify a string to match on these objects. And again, it has to do with these, with your properties. So in this particular case, I'm specifying that the department property is equal to marketing. And so what that will do, if I then use the method filter using predicate, using this predicate, I will get back an array that is a subset of my employees containing marketing.
NSPredicate is a huge class. We could do a whole course just on NSPredicate.
Yes.
But there is an NSPredicate programming guide.
Yes.
And loads of stuff in there. But again, very, very powerful stuff.
Yes.
And all integrated together.
Yes. So I'd say let's take a break at this point, and we'll come back and we'll look at some more of these collection classes, such as NS Dictionary and NS Set.
Okay.